I am Dr. Binu. In Digital Signal Processing subject, the third topic in the fifth unit is DSP architecture. DSP architecture refers to the specialized hardware structure used to perform signal processing operations efficiently. DSP processors are designed to perform mathematical operations such as multiplication, addition, and accumulation in a very fast manner. DSP architectures is the hardware structure used for digital signal processing operations. The main units for the DSP architecture are ALU, MAC unit, program memory, data memory, control unit, input-output interface. It supports fast multiplication and accumulation. It uses Harvard architecture and pipelining for high-speed operations, widely used in audio, speech, image, and communication systems. This diagram shows the components which are used for analog to digital as well as digital to analog. These are the major components in DSP processes. The simplified architecture of the DSP architecture is it consists of input interface and output interface with the program memory, control unit, arithmetic and logical unit, multiplayer accumulator unit, data memory, as well as program memory. The main components of DSP architecture are program memory, which stores instructions for processing, provides instruction to the processor. Data memory stores input data and intermediate results. Third, arithmetic logic unit performs arithmetical operations such as addition, subtraction, multiplication, division. Multiplayer MAC unit performs multiply accumulate operation, very important for filtering and convolution operations. Fifth unit is control unit, controls execution of instructions. Then coordinates all operations in the processor. Input-output interface handles communication with external devices like sensors, ADC and DAC. Key features of DSP architectures are Harvard architecture, that is separate data as well as program memory are available, pipelining feature, parallel processing, dedicated MAC unit, high-speed arithmetic operations. Types of DSP processors are von Neumann architecture, which consists of single memory for program as well as data. Harvard architecture, separate memories for program as well as data, so execution is faster. Modified Harvard architecture, also called a super Harvard architecture or SHARC. It combines the advantages of both architectures. Differences between von Neumann architecture and the Harvard architecture. In von Neumann architecture, the memory is single memory for program and data, but in a Harvard, separate memory for both program as well as data. Data part is single bus for instruction and data. In Harvard, separate buses are available. Speed, when we are comparing speed, von Neumann architecture is slower because a single memory shares the program as well as data. In Harvard architecture, it is a faster instruction fetch cannot occur simultaneously with data access. Instruction and data access occur simultaneously. Complexity is simple in design. Harvard is more complex. Performance, lower performance. Harvard is higher performance. Von Neumann architecture, here memory, single memory shares the data as well as a program or instructions. There are two buses, address as well as data buses. This single set of buses is used for data as well as instruction fetching. Harvard architecture, here two separate memory are available, programmer for program as well as data. So separate address bus as well as data bus is there because of the execution is very faster. Super Harvard architecture, that is or modified Harvard architecture or SHARC. Here frequently used instructions are stored in cache memory, which is very closer to the CPU. Because of this one, this architecture is more faster than Harvard architecture. Applications of DSP processors are which is used in audio processing, speech recognition, image processing, wireless communication, radar and biomedical signal processing. Thank you.